Welcome viewers, in this video we will see the details about asynchronous 2-bit up counter. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic asynchronous 2-bit up counter. We know that the counter is a digital device going for the counting purpose. Up counter means goes from 0 to maximum number. 2-bit, it is coming 2-bit. Asynchronous counter, we know there are two types available, synchronous counter and asynchronous counter. This is coming under asynchronous type. So this counter is made up of a flip-flop. Flip-flop is the storage element. It will be able to store 1-bit data. Now we'll see the detail. A binary ripple or asynchronous counter consists of series connection of complementing flip-flop, that is inverting. The clock pulse is inverted, so that is given complementing, with the output of each flip-flop connected to the clock input of the next higher order flip-flop. So that is called the asynchronous counter. Here n number of flip-flops are connected in series. Only the first flip-flop the clock pulse is connected. For the second flip-flop the clock pulse is output of the first flip-flop. Output of first flip-flop is connected to the clock pulse to the second flip-flop. Second flip-flop output is connected to the clock pulse of third flip-flop. So the operation is asynchronous. The first flip-flop depends upon clock pulse, but second flip-flop is depends upon output from the first flip-flop. So there is a propagation delay. So the clock pulse is not applied to all the counters. It is from output of one flip-flop is the clock pulses of the next flip-flop. So that it is called a asynchronous counter. The flip-flop hold the least significant bit, receive the incoming clock pulse. Only the counter, that's a flip-flop with the least LSB, will got the incoming clock pulse. The complementing flip-flop can be obtained from a JK flip-flop with J and K inputs tied together as shown in the diagram. J and K will get the same input, that is high input, logic high, right? So here we are going to use the JK flip-flop. J input and K inputs are tied together, that is common input as given as higher. Now we'll see the logic diagram. So here two flip-flops are connected, the flip-flop A, flip-flop B, JK type. The input is JK type, right? So for the first flip-flop LSB, this is LSB, so the clock pulse is connected. The clock pulse is connected to the LSB flip-flop. The clock pulse of the second flip-flop is nothing but output of first flip-flop. QA is given as a clock pulse to the second flip-flop, right? First flip-flop got the clock pulse. Second flip-flop, output of the first flip-flop is the clock pulse. So this flip-flop will respond to the clock pulse. This flip-flop will respond based on the output from the first flip-flop, right? Now the high input is given to JK flip. Both J and K is given as high, logic high is given. What is the nature of the JK flip-flop? If both the inputs are 0, 0, no change in the output. If both the inputs are 1, then it is toggle. 0 means 1, 1 means 0. That is the nature of the JK flip-flop. Now we are getting the 1 high as a input for J as well as K. So what will happen? If the QA is 0, it become 1. 1 means 0, 0 means 1. So every clock pulse, here the higher input is there. So the QA output will be toggle. 0 to 1, 1 to 0, 1, 0 to 1, like that it will goes. Right. Now this output is given as a clock pulse to the second flip-flop. So what happened? It is inverted. We know that this is a negative triggered clock pulse, right? We'll see what is meant by negative triggered and positive triggered. This is the positive triggered, changing from 0 to 1. Every rising edge, the state will changes. This is the negative triggered, that is during the falling, that is from 1 to 0. And the clock pulse changes from 1 to 0 during the falling edge. This is called negative trigger. So this is coming under negative trigger, inverted. This is positive triggering, this is negative triggering. So when the changes from 1 to 0, falling edge, the negative edge, during the negative edge, the state will changes. So what happen if it is 1 here, then 0 will be applied. So no change. This no clock pulse is not applied. Here 0 means, suppose QA is 0 means, here after inverted 1 is applied. So every 0, here the clock pulse is applied. If QA is 0, then the clock pulse is applied, the state will change. So every 0 output of QA, the state of the QB will changes, right? So every clock pulse, when the every clock pulse during negative edge triggering edge, the output of QA changes, right? Clock pulse, due to the clock pulse, QA changes. For every QA 0, the QB, the state of QB will changes, right? So based on that, we got the up counter, 2-bit up counter. 2-bit mean 4 combinations, 0 0 0 1 1 0 1 1. Now we'll see the clock diagram how we are getting the 4 different combination of the up counter. Up counter means 0 to maximum, right? So this is the counting, 0 0 0 1 1 0 1 1. The stages 0, 1, 2, 3. There are 4 stages we are getting. Now we'll see how we got this counting. So this is the clock pulse. 1, 2, 3, 4. We have 4 clock pulses available. We already discussed the negative edge. This is the positive trigger during changes from 0 to 1. This is 1 to 0. Changes from higher to lower. Negative trigger. Here it is connected with inverted. So every negative triggered, the state will change, right? So this is that also I already explained. This is the higher level to lower level. When the higher level to lower level goes, the changes will occur because of inverted negative trigger, right? So this is the QA, LSB. This is QB, MSB, right? QB and QA. Right. This QA is applied with the clock pulse. We know that the clock pulse is applied to QA. So every clock pulse, the state will changes. Initially 0. So during the negative change, negative triggered, negative edge, the state will changes 0 to 1. So up to next triggering. This is the next negative positive triggered. Similarly, this is negative edge triggered, right? So up until this next negative triggering, it is 1. So when the changes from 1 to 0, again it changes from 0 to 1 until this state. At this again it will changes, right? So I will mark here. So this is the negative edge triggering. So every negative edge triggering, the state will change. Positive trigger means here at this point the changes will occur because of this inverted. At this falling edge, at the end of the clock pulse, the changes will occur. So at this point 0 to 1, at this point 1 to 0, at this point 0 to 1 is keep on changing because QA, flip-flop A, is directly connected with the clock pulse. So every clock pulse, the state is changes 0 1 0 1 like that, right? What about the BQB second flip-flop? This output of QA is connected as a clock pulse, right? The output, the QA is connected as a clock pulse. So we already discussed whenever 0 occurs, there is a change, right? That is at this. This is the negative trigger. So this is negative trigger. This is positive, changing from lower to higher. Here higher to lower. See, this initially 0. Here and here this pulse is applied here only, negative. So it is the second stage also 0. At this point what happens? 0. We already told that 0 means due to inversion the 1 is applied. So at this position the state will change. State changes from 0 to 1 until the next negative edge, until this. So this is positive until this. This is the next pulse. This is the first pulse. This is the next pulse. During the first negative pulse, because of this, it changes from 0 to 1 due to the 0 applied. 0 is applied here. 0 means 1. So due to that 1, the state changes from 0 to 1. The same thing continues. So this is positive edge, no, nothing will happen, right? 1 means 0. This 1 means here 0 applied, so no change. Here during the negative, here 0 is there, right? 0 means 1. So again the state changes from 1 to 0, right? So I will explain again. Here 0 is there, first 0. Here 1 means 0 clock pulse is applied, so no change. 0 means 1 is applied as a clock pulse, so there is a change from 0 to 1. 0, 1 means 0 clock pulse is applied, so no change. 1 is maintained as it is. Here 0 means 1, inverted clock pulse 1, 1 is applied. 1 means changes from 1 to 0, right? So every during the negative trigger the state will changes. Here 0 changed to 1. Until the next triggering the changed. See, 1 is changed to 0, right? So this output is purely based on the clock pulse. This output is based on the QA output, right? Whenever falling negative edged, the state is changes. Negative edged means 0, 0 means 1. Negative edge 0, 0 means 1. So at the time changes, right? So based on that, this is 0, 0, right? 0, 0, 1, 0, 0, 1, 1, 1, right? So this is LSB, this is MSB, right? 0, 0, 1, 0, 0, 1, 1, 1. So that we got the 4 stages. I think you are able to understand. So every negative edge state changes 0 to 1. Here 1 to 0, 0 to 1, like that. Similarly here, this negative edge 0 is changed to 1. The next negative edge 1 is changed to 0. Now we'll see the description. What we discussed, the description is available. The diagram shows 2-bit asynchronous counter using JK flip-flop. As shown in the diagram, the clock pulse is connected to the clock input of the only the first stage of flip-flop. The clock pulse of the second stage of flip-flop is nothing but output of the first flip-flop. So that is triggered by the QA out of the first stage. QA output is the triggering pulse for second flip-flop. Because of inherent propagation delay time through a flip-flop, a transition of the input clock pulse and a transition of the QA output of first stage can never occurs at exactly at the same time, right? The first flip-flop depends upon the clock pulse. Second flip-flop depends upon the output from the first flip-flop. So there is a transition will not never occurs. Therefore, the two flip-flops are never simultaneously triggered, which result in asynchronous counting operation. So due to that, we are getting the asynchronous counting operation. That's why it is called a asynchronous counter. The timing diagram of 2-bit asynchronous counter is shown in the shown in the diagram. It illustrates the changes in the state of the flip-flop output in response to the clock. Right? Every negative trigger, the changes will occur. Because JK flip-flop, both the inputs are 1, it will toggle 0 to 1, 1 to 0. So every clock pulse, the state is changes. J and K inputs of JK flip-flop are tied to logic high. Hence, output will toggle for every each negative edge of the clock pulse. That's we discussed. J and K is high means it will toggle. Now we'll see the operation. What we discussed, the description is given as a operation. We'll see this one by one. Initially, both the flip-flop be in the reset state. QA and QB is 0, 0. As soon as the first negative clock edge is applied, F flip-flop A will toggle and QBA will changes from 0 to 1. So while applying the first clock pulse, the QA output changes from 0 to 1. But at this instant, the application of negative clock edge QA, JB and KB is 0, because it is this 1 is applied means, what is 1 is applied means 0. Here, hence flip-flop B will not change its state. So the QB will remain 0. Right? When 0 is applied, it become 1. But here 1 is applied. Because of inverted, it become 0. So QB and QA is 0, 1 after the first clock pulse. Initially, 0 0 now changed to 0 1. So on arrival of the second negative clock edge, the flip-flop A again toggle again and QA changes from 1 to 0. Initially 0 to 1, now become 1 to 0. Now this 0 is applied. This is because of negative edge. When the 0 is applied, it becomes 1. Then there is a change in the flip-flop 2. But at this instant, QA was 1. So JB KB equal to 1 and flip-flop B will toggle. Hence the QB changes from 0 to 1. In the first stages not changed. Flip-flop B not changed. 0 is maintained as it is. Because of this 0 input negative edged, this flip-flop B will toggle from 0 to 1. Now the status is QB QA is 1 0. Initially 0 0 0 1 now become 1 0 after the second clock pulse. Now we'll see the third clock pulse. What will happen after the third clock pulse? On application of the third falling clock edge, FA will toggle from 0 to 1. Again it will toggle. But there is a no change of state flip-flop B. Right? Because of 1. 1 means no change. 1 means 0 is applied, no change. So QB QA is 1 1 after the third clock pulse. So flip-flop A toggles for every clock pulse. Flip-flop B will toggle when the state is 0. If it is 1, it will not toggle, right? Because negative edge. The output of counter is incremented by 1 for each clock transition. So such counters is called a up counter, 2-bit up counter. So in this video we discuss asynchronous 2-bit up counter. We discuss the logic diagram, timing diagram and the construction followed by the operation. Every clock pulse what will happen, right? So the flip-flop A, the state is changes when the every application of negative edge clock pulse. Flip-flop B, it will change when the output of first clock pulse is 0, it will change. 1 mean will not change because of negative. So based on that we got the 4 different states. So that it is called a 2-bit up counter. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.